In this video, I'll demonstrate and explain what a tangent axis is and when an auxiliary axis would be used in MotionWorks IEC. Hi, I am Micah Studeman. Here's a quick preview. Tangent following is used to rotate a directional tool to follow a predefined path. The Y-sync tangent axis to group function block performs the complex task of following the motion path with the rotary tangent axis. Auxiliary axes are used to add motion to a specified mechanism beyond the basic X, Y, Z, Rx, Ry, and Rz components. This is useful for controlling multiple extruders or multi-axis tool heads. Now let's look at this in a little more detail. To illustrate the tangent following concept, I'm using a virtual gantry that is being controlled by a 3-axis MP3300 IEC and Sigma 7 demo, and has a tool head attached to the Z-axis that can rotate 360 degrees. Running the program, the tool head goes to a predefined start position and rotates the knife to start cutting the following shape. As the gantry moves along the path, the tool head rotates the knife so that it stays tangent to the shaped path on the XY plane. At non-collinear angles, the knife will lift out of the material to rotate so the material and the knife are not damaged. The complex tangent rotation is handled by the Y-sync tangent axis to group function block. The programmer provides the correct input information, and the function block manages the rotation of the path following tangent axis. So what is tangent following and why is it needed? There are a lot of different applications that perform cutting, otherwise known as subtractive operations. These machines consist of CNC mills, lathes, glass cutters, wood routers, and laser engravers and cutters. Different tool heads are required to perform the cutting operation. Some of these tool heads are direction dependent and some are not. Direction independent tools can cut material on any plane in any direction. An example of this tool is a milling bit. A milling bit rotates and can cut material in either direction. On the flip side, direction dependent tools can only cut in a set direction. An example of this tool is a knife blade. A knife blade can only cut the material where the blade is sharpened. The blade needs to rotate so that the sharp edge is always tangent to the path. Being tangent means to touch but not intersect a curve. This allows the knife to smoothly cut around curved and straight paths. Sharp corners in the path may need to be dealt with in a different way. If a direction independent tool was used, the tool head would just continue cutting along the path. With the direction dependent tool, if the blade was rotated in the material, it could rip or tear the material or break the knife blade. The blade needs to be lifted out of the material, rotated, then plunged into the material to make the next cut. This allows the material to stay intact and the blade will be less likely to break off. The programmer needs to specify the rotation required for the knife to line up for the next cut. This can be done using the unit circle. You can see that by this animation that at every hard corner the knife blade rotates to a set degree angle of the unit circle. This can be done with a move absolute function block. The Y-sync tangent axis to group function block synchronizes the motion of the tangent axis to a multi-axis mechanism. The single tangent axis needs to remain separate of the group to use this function block. Looking in hardware configuration, the tangent axis is separate and not included as part of the gantry mechanism. Tangent operation is only available when the path resides on the following two-dimensional planes: XY, YZ, or ZX. In the case of the virtual gantry, the tangent axis is the knife and the multi-axis mechanism is the 3-axis gantry. The path is being cut on the XY plane of the gantry. By the way, Compass, along with its template, has tangent following built in. Compass is a user interface that streams G-code commands to the controller, which then moves a multi-axis mechanism. Tangent following can be used on different types of mechanisms other than just gantries, because it is controlled separately of the group mechanism. All of these mechanisms are supported in MotionWorks IEC. Unlike a tangent axis, an auxiliary axis is part of the mechanism group, even though it is not considered part of the basic 6-axis directions: X, Y, Z, Rx, Ry, and Rz. The group menu inside hardware configuration allows an auxiliary axis to be added to the group. Once added, this axis can be used within the group structure for motion. Up to 6 auxiliary axes can be used on one mechanism as long as the total mechanism axis count does not exceed 10. Moving an auxiliary axis can be done by using a group move function block and setting a position to vector element 7, which is aux1, through 12, which is aux6. Why is this useful? The aux-axis feature allows tools that have feed motors to be grouped in with mechanism axes for simplified motion. Some example toolheads are wire feed welders and 3D printer extruders. Using the example of the 3D printer extruder, it has a motor that turns and dispenses plastic onto a build plate. Having auxiliary axes allows one or more extruders to become part of the mechanism. Instead of using separate single-axis move blocks to feed the material, this motion can be grouped with the mechanism motion. So when a part is being printed, the extruder feed positions are sent with the mechanism positions and are handled by one move block. Thanks for watching this video. Go to yaskawa.com/IECSW to download the latest version of MotionWorks IEC 3 and try out these features yourself with a 30-day demo.